Hello guys, and welcome back to another Sonic tutorial. This is the second video of this series regarding ABAP objects and our object-oriented programming. If you haven't watched the first video, I strongly recommend you to. So the link to the first video is at this video description, right below the video. Right below the video. So today we are gonna be talking about abstract classes and polymorphism. How to use it, when to use it, and why. Mostly why should you use it. Okay, at our previous class we created this class Pokemon, which we are staring at right now. If you go back to the diagram, we have our class Pokemon with name, health level, and two methods, constructor and attack. Okay, that sounds like that's pretty much what we did. Okay, so let's talk about polymorphism. So we have created a Pokemon called Pikachu right here, okay, which is type reference to Pokemon, and we have created our Pikachu, and we asked Pikachu to attack itself. Okay, but what if I wanted to create another kind of Pokemon? Right, so what if I wanted to create Charizard, for example? Like, so I'm going to declare a new variable, type reference to Pokemon as well, right? And down here, I'm gonna create object Charizard. I'm gonna change its name to Charizard. That sounds that sounds good, you know. Now I have Pikachu and Charizard, and I can ask Pikachu to attack Charizard, and I can ask Charizard to attack Pikachu. That sounds like fun. They're having a good battle right there. But in fact they are not. Even though Pikachu and Charizard, they have lots in common, they are not exactly the same thing. Okay, so let's talk about the attack method. Every Pokemon knows how to attack, you know, besides Magikarp, but who cares? And but each Pokemon has its own individual way of attacking. Each Pokemon has its own kinds of attacks. So, I don't know, Pikachu has like Thunderbolt and Charizard has Flamethrower or something like that. I'm not a specialist in Pokemon, sorry guys. And now, I'm telling Pikachu to attack, but the code here that is going to... The code for attacking is the same code for both Pikachu and Charizard. So what should I do if they both have different kinds of attack? What should I do? So, oh, I know what we should do. We can create like case me name if Pikachu, right? Pikachu attack when Charizard, right? Charizard attack. That sounds good, doesn't it? That sounds beautiful. And how? Well, if you ever write something like this, please go find a shrink. You're not feeling good. This is definitely wrong. You know, if we have like 200 kinds of Pokemon, you're gonna create a case with 200 cases. This is disgusting. Please. And that's when abstract classes come in handy. So let's go back to your diagrams. I'm gonna copy. This is where I was going. Okay, so we have our class Pokemon right here with its attributes and methods. This is a concrete class. Right now, this is a concrete class, which means it's not abstract. You know. This is the definition of Pokemon. But now you might be wondering, you know, I don't know how many Pokemon there are, but I guess plenty of them, and all of them share the same. All of them share some basic attributes and actions like name, health level, and attack. You know, but you don't want to copy that code. You know, for example, if I want to have two different kinds of attack, you might be tempted to do something like this. You might be tempted to change your Pokemon to Pikachu, right? So now you have a class Pikachu, and you're just gonna copy that, paste that, and replace Pikachu with Charizard. Okay. No, that doesn't sound right. Hold on. Pikachu with Charizard. Okay. Now we have now Pokemon. Now Pikachu and Charizard have different attacks methods, right? That sounds right, okay? That doesn't sound right. Please, bitch. That's, oh my god. I can't believe I've written that. You have just killed a very fundamental concept about clean coding, which is duplicity. If you have the same code in two different places, something is not right. Something is definitely wrong. So let's say we have 300 Pokemons. I'm gonna create 300 class, and I'm gonna declare 900 attributes. I'm gonna declare 600 methods. That sounds like just a little work, right? That doesn't sound right. And then, for some reason, the company that produces Pokemon releases a new version of Pokemon, and now every Pokemon has a new attribute. Let's say stamina or magic points. You have 300 classes to maintain. You're gonna have to change these attributes in all 300 classes, and that's not what you want to do. That's completely wrong. What you want to do is you want to take every single aspect and every single action that every Pokemon has in common, and you want to centralize that information in one single place. And this place is called the abstract class. Now, if you look at Pikachu and Charizard, what do they have in common? You know, what are they? What are they? What are Pikachu and Charizard? They are both Pokemons. So now we're talking about the concept of concrete and abstract. Concrete and abstract, okay? Let's say our real world has Pokemons to make it have more sense. In the real world, you don't have a Pokemon called Pokemon. You have a Pikachu, you have a Charizard, you have Bulbasaur. These are all concrete Pokemons. They do exist, but Pokemon itself is an idea. There is no such Pokemon called Pokemon. You know, Pokemon itself is an idea of Pokemon. The same thing goes for persons. Let's say, to make this more clear, we have me, right? So Necro, and we have you, Vero, you. We are both different people, right? But what do we have in common? I don't know you. You don't know me. We don't need to know each other, but we do have something in common. You know, besides liking Pokemon. We are both people. So we have an abstract class called person. And we both inherit from person, which means we are both person. We are both people. Sorry about my English. Now this sounds good. That's the word we're looking for when we are talking about abstract classes and polymorphisms. It's the word inheritance, which is very tough to pronounce for me. So I'm sorry in advance. We are two different people, but we all share the same characteristics. So we all have, I don't know, let's say we all have a name, we all have ages, we all have an ID, we all have, I don't know, color, sex, whatever, you know. And we have what we did right here is we centralized our main attributes in one abstract class. And every time a new person is born, like so, let's say a new person is born, newborn. Okay. Every time a person is born, it's going to inherit from the abstract class person, and automatically this newborn also has the attribute name, age, ID, color, and sex, even though I didn't declare it in the newborn class. I don't need to declare these attributes again to every new person in the world because they're going to be inherited from the superclass. Person is the superclass of Sonicro and you and the newborn, and Sonicro is the subclass of person. I hope you guys understood that. So back to Pokemons, we have the concrete class Pikachu and we have the concrete class Charizard, right? And we have the abstract class Pokemon, which is the idea. So everything there are in common between these two types of Pokemon is going to be defined and implemented at the abstract class Pokemon, right? And sometimes the implementation is not in the Pokemon itself. So let's head back to our ABAP program, right? And let's erase this shit. Nobody saw that. If someone asks, that wasn't me. Okay, so let's delete everything. We're gonna change this class name back to LCL Pokemon, and now definition abstract. We are telling that our class is abstract, therefore cannot be instantiated, cannot be you cannot create an abstract class. You know, you can't create a Pokemon without fully specifying what kind of Pokemon do you want to create. Do you want to create a Pikachu or do you want to create a Charizard? Right. So just so you guys know, I'm not lying to you. I'm gonna try to create an object here. Create object. So create a Pokemon. Oh, the compiler doesn't like the idea. A class Pikachu. That doesn't like. Oh, sorry, that's not Pikachu. That Pokemon. You cannot generate instances of the abstract class LCL Pokemon. Yeah, the compiler is very smart. Good guy. You know, because we need to specify what kind of Pokemon we want to create. So now we have declared our methods and our attributes in the Pokemon class. So every subclass of Pokemon is going to have access to these things. Or do they? They are not. So let's go back to public, private, and protected section. In our last tutorial, we declared our attributes in the private section. So only the class Pokemon has access to these three attributes. Now, if I create another class called Pikachu and inheriting from Pokemon, what's going to happen is I'm not going to have access to these attributes because it's private. It's for the class only. And there is when the protected section comes in handy. Now you have something. You have some attribute, you have some method that you don't want to make it public, you know, you don't want people messing around with your attributes or methods, but you want to give permission for your sons, your kids, your child, your subclasses to have access to this kind of information. And that's the protected section. Everything you declare inside the protected section is private to you, right? So it's not public, so people outside your class cannot see those information, but every subclass of you, every single thing that inherits from you can. Right? So that's why the protected section only makes sense when you're talking about polymorphism and inheritance. Good. I think that sounds like that. The public section is going to be inherited regardless. So, you know, it's public. Okay, that sounds good. Now. That's not good yet. Do you see right here the method attack? You know, I can implement the constructor of Pokemon, you know, because these 3 lines of codes right here is going to be the same code for every single Pokemon I create, okay? Regardless of type, regardless if it's Pikachu or Charizard, this constructor code is not changing. But the attack method, by the other hand, will. So I can't implement the attack method in the Pokemon class because I don't know what kind of Pokemon is going to be created. But what I do know is that when a Pokemon is created, it must have a method called attack. Okay, so this method is what we call an abstract method. Abstract, I don't know, I forgot how to write abstract. Is that like before? Oh yeah, sorry. I forgot how to do that. So what we did was we have declared that our attack method is abstract. And why do we need to do this? If we don't use the keyword abstract and we try to check for syntax, it's gonna say the implementation missing for method attack because the compiler thinks that attack is a concrete method and should be implemented in the Pokemon class, but it's not, because Pokemon itself doesn't know how to attack. That's why I have to specify that this method is abstract. Therefore, the compiler will agree with us and say, okay, carry on with your development. Now, this is starting to get fun, you know. This is starting to get very interesting. This sounds okay. Now, if you go back to our class diagram, we have Pikachu and Charizard. If you notice, I didn't declare the attributes again, nor the methods. I'm going to declare the methods again because we are going to implement these methods for each individual Pokemon. Attack. Right? I don't need to declare the attributes again because they are inherited from the superclass. Okay, that sounds good. Now we are gonna create our Pikachu class. So class LCL Pikachu definition inheriting from LCL Pokemon. Oh, that sounds like a final. By final, it means that it cannot be inherited. It's like I'm telling you that there are no going to be. Hold on, my English failed. There are not going to be any kinds of Pikachus, therefore you should not inherit Pikachu. Okay, that's the function of the final keyword. Okay, so we're gonna. Do I need to declare the protected session again and declare the attributes? No, the answer is no. Automatically, your Pikachu class is going to have everything that its superclass has. Alright, so okay, this sounds like good. Public section. Now, at the public section of my Pikachu, I'm going to be forced to implement the attack method. And why the hell should I be forced to do something? No one can force me to do shit. Yeah, the compiler can. This guy has such power. Oh my god. So if a class is derived, I don't know how to pronounce that, sorry. If a class is derived from an abstract class and not all of its abstract methods, for example attack, are redefined, you must define the class as abstract. So what is the compiler talking to us? What is the compiler complaining about? So when we were at the Pokemon class, and the compiler was expecting us to implement the class attack, and we said to the compiler that the attack method was abstract. What we did is we passed the job of implementing this method to our subclass. Right? So I don't need to know how you attack. You deal with your shit, you know, leave me alone. And the compiler is actually, you know, it wants you to do that because you have created a concrete class here. Pikachu is a concrete class, it's not an abstract class. So therefore you must implement every abstract method in a concrete class. If you don't want to implement that abstract class, therefore your subclass should also be abstract. So let's say I have two kinds of Pikachu. I don't know. We could say that we could say that Pikachu is abstract and the compiler is not going to complain anymore. But then I would have to create, like, I don't know, Fire Pikachu. I know that's like a sin I'm doing right here. I'm killing the Pokemon story, but who cares? Definition in class. Oh, sorry. Inheriting from LCL Pikachu. Oh, good. The final class LCL Pikachu cannot have any subclasses. Why? Because of the keyword final. Yeah, we have learned something new here, kids. So, going back, the compiler is going to always ask you to implement the abstract method unless the class is abstract itself. So this is not the case. I was just, making fun, having some fun. There is no such thing as Fire Pikachu, which would be cool, but okay. So we're gonna redefine the method attack. Methods attack redefinition. Oh, that sounds good. I forgot to do the implementation. Class LCL Pikachu implementation and class method attack. Now the compiler is happy with us. He actually wants us to have a good day. And if you noticed, we didn't have to declare the parameters again. You just need to inform that you are redefining the method attack. So it automatically understands that these are the parameters, and you cannot change the parameters of a redefined method, nor the section in which this method is contained. So let's say this is a public method, right? If I try to redefine the attack method in the private section, I will not be allowed. Yeah, you shall not pass. When you redefine a method, you cannot change its visibility. It doesn't make sense to have like a method in the public section and you try to redefine that as a private section. You're not allowed to do that. The superclass defines if the method or attribute is public or protected or private, not you. Your job is only to implement it, to redefine it. Okay. And redefinition works even if the method is not abstract, But when a method is abstract, you're forced to implement that method. And when the method is not abstract, you are not, but you can also redefine the method. But we're gonna go through that later. So now we can control the way our Pikachu works, and that's beautiful. With no duplicity, we don't have any line of code that represents the same thing in this code. This is good. I love this. So anyway, let's see. I'm starting to like this. So our attack methods receives another Pokemon as a parameter. Okay. So what can we do? For now, we're not gonna do anything too complex in the attack method. We're just gonna write Pikachu attacks, something more exciting. Thunderbolt. That sounds like fun. Okay, so now we notice that we have created our Pikachu class, and we have taught our Pikachu how to attack. Yeah, our Pikachu is growing. So now we're gonna create that Pikachu. We're gonna create. Oh, but I cannot generate instance of abstract classes. What should I do? Shit. And that's when the type keyword comes in handy. So I'm creating an object Pokemon of type Pikachu. This is awesome. It's gonna ask for the constructor parameters, which I forgot. Fuck you. Anyway, these are the parameters. Exporting, and the name is going to be Pikachu, and the health is going to be 100, level 1, newborn. Great, we have just created our first case of successful polymorphism using abstract classes. And now we're gonna ask our Pokemon to attack. Okay, go Pokemon attack. It's gonna ask for a parameter because we are going to use the parameter, but not right now. So I'm just passing myself so the compiler doesn't complain about missing parameters. Period missing. Pokemon. No, you're not a man, dude. Okay, so let's see what happens when I try to run this code. Look, Thunderbolt. Oh, that's interesting. Let's see what happens right here. We're gonna set some breakpoints. Let's set a breakpoint right here. So let's run our program. Right now, if you go to Pokemon, you can see that the technical type of this reference variable is LCL Pokemon. Okay, and is initial. We have instantiated that yet. Now I'm gonna press F5, and it's going to the technical type of our variable is still Pokemon. Okay, and now it's going through the super constructor, as we say. So it's going to initialize the class attribute, and after that, let's look. This is very interesting. F5. Look what happened. Nothing happened. Shit, I was not expecting that. Sorry. Oh no, hold on. See that's what I'm gonna tell you. In runtime, our object became an object of type LCL Pikachu. Even though we have declared our variable as Pokemon, in runtime we have specialized this object into a Pikachu. See, that's very interesting. That's nice. So therefore, when I play F5, even though the attack method of Pokemon is abstract, in runtime, this reference variable Pokemon is now pointing to an instance of a Pikachu. Therefore, it knows how to attack. Then it's going to go to the attack method of Pikachu. Great! Sounding good. Okay. Oh my god, 28 minutes. Let's create Charizard very fast, very quickly to finish this tutorial. We're gonna create our class LCL Charizard. Definition inheriting from LCL Pokemon. And we're gonna redefine the method attack as well. Okay. Method attack. Okay. And our Charizard is gonna write flame throw. That's too difficult to write. That's just fireball. Yeah, that's simpler. That's more simple. Fuck. Okay. Good. So now to the interesting part. We have a variable that is referenced to Pokemon, and what are the advantages of using the abstract class besides, all we have learned already? With only one kind of variable, when I declare a variable type reference to Pokemon, this variable can handle with any kind of Pokemon, with any subclass of Pokemon. Regarding if it's a Pikachu, if it's a Charizard, we don't need to change that. See, so I don't know if you realized that the attack method is importing a variable of type reference to Pokemon. But just so you know, if I declare a variable of type reference to Charizard, and pass this variable into the attack method. The compiler is not going to complain at all, because even though LCR Charizard is not the same as LCL Pokemon, it's still a subclass of Pokemon and therefore should be accepted. That's pretty much, this drawing says it all, you know, this drawing explains everything. It's the idea is very simple, you know. We're gonna create a Charizard in a different way, so you can know both ways of creating objects, objects through polymorphism. If I create the object Charizard, oops, sorry, what happens? See, I didn't have to specify the type right here because we have declared Charizard as type reference to Charizard. So you cannot create anything besides a Charizard using this reference variable. So you have two ways of creating these classes, these objects right here. And this is the first way, using the superclass and specifying the type. This type can be dynamic, you know, you can use a variable right here, like LCL Pikachu. Oh, this is very interesting. We're gonna do that. You're gonna go crazy, I know. I'm gonna just be name. I liked the idea. We're gonna do that. Yes, we are. Okay, I guess that's it for now. I'm gonna create two quick parameters just to have more fun. Name, type. What is the type for this? String. Okay, string. And P class type SEO name. I guess something like that. This is the data element for class name. Okay, so we are gonna create a Pokemon in runtime. This is gonna be so much fun. Oh my god. Just kidding. Look, this is gonna be awesome. What am I doing right here? I'm creating a Pokemon and I'm specifying the type of Pokemon I'm creating on runtime. Oh boy, this is going to be so much fun. F8. So I'm gonna create a Charizard of class LCR Charizard. Let's run and see what happens. Okay, F5, super constructor, so far so good. Now, if we open the reference variable Pokemon, you can see that its type in runtime it has specialized itself to LCL Charizard. Therefore, when I run the attack method, it's going to throw fireballs instead of thunderbolts. Yay! Now if you go back and change this to Pikachu and LCL, Pikachu, LCL, Pikachu, and run our program, let's see what happens. It's going to go to the super constructor as well. And then our reference variable now points to an object of type LCL Pikachu, and when I call the attack method, it's going to throw thunderbolts. That's beautiful, isn't it? Yeah, that's the power of polymorphism and abstract classes. I'm taking too long to do this tutorial, so I think I should end up right here and leave more fun stuff for next tutorials. For now, that's it. I think you can, by learning how to correctly use abstract class and inheritance, a whole new world of possibilities is going to open to you, and you're probably going to write very awesome codes, you know. For now, that's it, and thanks for watching again. Bye-bye.